Hello, and welcome to our webinar, Automation in Abaqus using Python Script and GUI Toolkit. Just a couple of housekeeping items before we start. If you have any questions, please post them in the question area and we'll get to as many as possible. Also, we'll be sending out the replay of the webinar shortly after its conclusion. And now I'd like to introduce our presenters. Arindam Chakraborty is the Managing Partner and CTO here at Bias. He is a mechanical engineer with more than 10 years of strong academic and consulting experience in solid mechanics and design, nonlinear FEA, fatigue and fracture mechanics, reliability analysis, composite structures in oil and gas, nuclear, and structural design. Syed Jaffrey is the FEA instructor and consultant at Bias and has over 10 years of experience in the oil and gas industry. His engineering expertise includes nonlinear 3D FEA of static and dynamic mechanical systems, modeling of machine vibrations, analytical and numerical CAE, modeling simulation of a broad range of engineering structures and machines that are utilized from onshore, offshore applications to automotive, aerospace, and wind energy. Christopher Habura is a senior FEA engineer here at Bias. He's also a mechanical engineer with more than 15 years of experience using the Python programming language for creating pre- and post-processing scripts and customized GUI applications to interface with Abaqus CAE, as well as standalone Python scripts and GUI applications to automate workflow outside of Abaqus. And with that, I'd like to hand it off to my colleague Syed.
Hello, good morning and good evening, everywhere, all of my fellow engineers all over the world. Thank you very much, Michelle, for giving a kind introduction to about Bias and about us. So here we are going to be doing a webinar on a very interesting topic on automation of analysis in Abaqus using Python script and GUI toolkit. And my name is Syed Jaffrey. So our agenda is we'll talk a little bit about ourselves, Bias as a company, what we do, and how we develop and do the simulation and analysis. Then we will come straight to the main topic of the webinar, which is the purpose of analysis, automation, and examples, followed by some really good examples and interesting examples for the automation and customization within Abaqus CA. And then my colleague Chris will be showing you a live demo for the kernel and GUI script, and then the remaining part will be about the question and answer sessions. So company overview. So who we are. So we have a multiple industry experience. We are basically a data analytics company. We perform high-level, very complex numerical simulations using finite element analysis and other tools such as CFD in the mechanical and structural regions. So we have multiple clients all over the world, including from the oil and gas, machinery and equipment for petrochemical and process, aerospace, medical devices, life sciences. And we have the presence in USA, Canada, Mexico, and India. We have a highly qualified team, which consists of 50 plus employees with 5 MBAs, 8 PhDs, and 7 MS MTechs in design, manufacturing, solid mechanics, numerical analysis. We provide the engineering and PLM consultancy, training for the Abaqus and several other softwares, sales and support, automation and customization, which is the main topic of our presentation today. And we are the value-added resellers for the Dassault system, Simulia. So we basically sell and provide technical services and support in Abaqus, iSight, FESafe, Tosca. And on the CAD side, we provide the same services for the CATIA, Delmi, and Canovia. And this is a quick slide on our technical capabilities, what type of engineering services and technical capabilities that we offer. So we offer from the local 3D FEA modeling, component design and validation, to the multi-physics simulations, which can include CFD, flow analysis, thermal, fracture-based, FEA-based fracture and damage mechanics analysis, design optimization and reliability using iSight and several other tools, structural analysis and vibration simulation automation, composite modeling and analysis, and electromagnetics. So this is just an overview of our capabilities here. And then we have a very, very hardcore specialization in the fitness for service level 3 assessment for different types of structures, which include the pipelines, basically the drums and the tanks and several other infrastructures, so we can model the fracture geometry, and then we can predict the performance of that structure and the growth of the crack based upon the codes. Um, as far as the CFD capabilities are concerned, we have specialization in CFD as well. So CFD, we have several tools to perform it: the fluid structure interaction, combustion, separation, blast and explosion, thermal FSI, and thermal stasis. So if you are interested in any of those consultancy services or the training, you can contact us directly, and then we can provide more details to you about it. So this is just an overview that how do we approach this uh, simulation and automation solutions for a particular problem. So we have the subject matter experts. So subject matter experts, they have industry experience, they have extensive experience in solid mechanics, structural mechanics, materials, nonlinear FEA, and based upon their knowledge and understanding of the problem, then we proceed ahead and develop a workflow. We perform the design automation kernel. We develop specialized scripts. So we have specialization in the scripting. And then based upon that tool that we develop, then we can get the desired output and we can provide a valuable tool to our customers. So now I will come to the first main section here about the analysis automation and tools and examples, supplemented by some tools and examples. So the first question that may come to the new user to his mind is this: that why do we do scripting in Abaqus? So you see here that based upon your industry experience or some research experience, you may have seen that sometimes you have to do repetitive tasks. I mean, you have to develop variants of a very similar type of model. And for example, if a model takes 1 hour to develop, just for doing the pre-processing, applying the loads, boundary conditions, geometry, meshing, etc., etc. If you develop a tool that can do it in a fraction of a second, basically 5 seconds, and your model is all done, then you can save your valuable 1 hour per model. So for example, if you have to develop 10 models with slight variations, you might as well develop a script. You have to first of all write down the script, but once that tool is there, then you can automate that repetitive task, and it really makes your life much easier. You will save your valuable time to dig more into the details of the model and then do the post-processing as well. So here it can range from the model building, job submission and monitoring, doing the post-processing, prescribed default behavior. So all of this can be automated using Python scripting coupled with Abaqus. You can extend the functionality by performing certain tasks which might be very difficult to do directly in Abaqus CA. So you can define them in terms of certain parameters in a Python script, and then you can enhance the interface using the graphical or non-graphical scripts. So non-graphical scripts are called as kernel scripts, and then the graphical scripts, we will also talk about them, which are called as the GUI scripts. So in short, the customized application, it provides automated environment for the experience analysis. For the non-experience analysis, it provides advanced analysis functionality. So for example, if someone is not very well versed in Abaqus CA interface, he can still use a Python script. Someone may create a Python script for him, and then at least he can get going and he can at least do the pre-processing part more easily and submit the jobs and get to the results. So this is the application of some of the applications of the Python scripts here. So I will just touch very briefly about the basics of Python. It's a general purpose interactive object-oriented and high-level programming language, and its coding is very easy to learn. It's not very difficult, but it's better that you should have at least some understanding and some background, little bit background of any programming language such as Basic, Visual Basic, etc., or C, C++. That helps really, but that is not an absolute prerequisite. You can start learning it from the very beginning. It's not a complex code. So it was first introduced in 1991. And a very powerful thing which has happened with Abaqus and Python is this: that Abaqus has adopted this and embedded the Python within its product line. So now Abaqus and Python can directly talk to each other, and the interface is so clear and so clean that you can create a Python script and you can run it from Abaqus and it will do the job for you. So why do we want to learn Python? It's, as I mentioned to you, it's friendly, easy to learn and free. So you can download it from the web. Powerful and readable, object-oriented and strongly typed. memory management, etc. And very importantly, in the context of this webinar, where can you use Python in Abaqus? So you can use it, as I mentioned to you, in doing the pre-processing, building the model, create, modify, and access, submit and monitor the jobs, and parametric study while you want to vary several parameters across a model, and doing the post-processing, so access the ODB and then customizing the ODB outputs, which also can consume considerable amount of an analyst's time. Just as I mentioned as a passing here, that as I mentioned to you, that besides Abaqus, we have several other tools suites such as iSight, FESafe, and Tosca. So iSight is one of the very good framework software package in which you can embed your simulations or your workflows to automate the design of experiments or the optimizations. For example, in a simulation model, if you want to come up to certain dimensions, optimized dimensions, so you can specify and configure it within iSight, and then you can embed those components within iSight, and you specify the criteria, and then iSight will change the parameters and run it for you rather than you going manually into the script or into the Abaqus CA and changing the parameters to come up with an optimized design. And it really reduces the room of error to come up with any design of experiment or the optimization study. So here it's basically generally made in terms of this type of flow is called as a sim flow. Here some of the plugins which are available on the 3ds.com. I'm just showing you some pictorial pictures here, and you can go into the website and then search the knowledge base, and then you can find out several plugins which are available for free downloads suitable to your application. Or if you know how to change the code, then you can modify it and change it according to your application. So it's a honeycomb model here, so you can assemble it, apply the loads, and then you can simulate this beam. This is a plugin for developing a board front-end washer assembly. Then, for example, if you have this plugin is about if you have a point cloud XYZ coordinates of data, you can use this plugin to generate an airfoil profile from here. Then for the rotodynamicists who are mostly interested in the structural vibrations of the rotating machinery and rotating shafts, this is a plugin for developing and doing the post-processing for the rotodynamic problems here. So, and as I mentioned to you, there are hundreds and hundreds of examples, so you can find them very easily on the 3ds.com. You just need to create your own user ID, and it's free of cost, and you can just go in there and basically search for those plugins and download them. So here in this section, I'm going to be talking about the automation and customization, supplemented with some interesting examples here. So in this slide, what we are trying to show you is this, that Abaqus customization with Python, this can be accomplished by writing a kernel script. So a kernel script is something that does not change the graphics or the graphical user interface of Abaqus. What it does is this, that it is simply a code which can be written in a notepad or textpad file. It's a code that is accomplishing something, such as building a model or creating a model or selecting some parts or surfaces, etc., etc. Or it's a code which is performing some post-processing, some specific post-processing task for you. So it will not change anything in the graphical user interface of Abaqus, but it will perform certain tasks which are defined in there. Then the next level to the kernel script is the really simple graphical user interface plugin. So here in the kernel script, you will not be seeing any pop-ups or basically any type of dialog boxes. In this one, we take one step forward, and it's kind of a mix between a kernel script and the graphical user interface. So here we can modify it to actually change it, bring some dialog boxes through which you can modify certain parameters, and they look graphical in sense, but they are not strictly completely graphical user interface. That is why they are called as really simple graphic, RSG plugins. Then the next step in more complexity is the standard plugin. Standard plugin is like more advanced than as compared to kernel and really simple graphical user interface plugins in the sense that you create the code in such a way that it will generate its own dialog boxes and its own way of accepting the user input data and then selecting several types of options. So I'll be showing you several examples of them in this. So in generally, I mean, as you proceed from here to here, it requires more expertise in developing the scripts and in writing scripts and more sophisticated tool, all within Abaqus. So custom toolbar buttons here in the custom toolbar buttons, as you might be familiar that you can create your own customized toolbars if you are going to be using most of them in a model, then you can bring them in Abaqus CA and assemble them together. Then this custom application is basically the GUI, graphical user interface application. It modifies look and feel of Abaqus. It looks like as if it's another software, sort of a software within a software. It's like another application that you can develop in Abaqus for very specific purposes and for users who are really focused on doing certain tasks and some certain complex tasks fairly repeatedly. Then this is where this application for the custom application GUI comes. And then the subroutine. Subroutine is neither an automation or not any other thing. It's basically customization in its own. It's not a script. But what subroutine does is this, that, for example, suppose that in a model you have very complex loading or boundary conditions or very highly nonlinear material model, which is not present on default in Abaqus. Then you can write your own user subroutine and reference it in the input file. The input file will fetch that user subroutines such as the foreground file and then perform the analysis based upon it. So I'll be showing you all of these through some interesting examples. So these are some kernel and GUI script examples taken from the knowledge base in Abaqus. So here, for example, on this left side, it's like a femoral component sitting on top of another implant. So using these commands, you can detect how much is the interference between these two components, because you want to avoid the interference before you start the analysis for the sake of convergence problems. Here on the right side, it's another example which basically shows you how to perform some very customized type of post-processing. So you can select and make the cuts and all of this using this type of plugin. So these are very customized applications, because I mean every time if you stop STM to do very specialized cuts or the selection of some elements or materials, it will take considerable time. It may take maybe 5 minutes to 10 minutes to come up to the ODD. Here, if you run this application, this type of application, it can perform the post-processing for you maybe within a minute or within a few seconds. So that's huge application and huge advantage of using the scripts. So here I'll begin with some really simple type of script kernel script example one. So it's creating material. So here, this is the script, snapshot of the script that I developed. And here it is basically referring to the model one in the model tree, as you can see here. Then it's calling for the materials action, so materials property. And then I'm calling this as a name uranium. And then I define the density and the elastic modulus. So using a very simple code, I mean, I can always automate the creation of the materials. I mean, of course, I can create the materials, but suppose that if I'm going to be producing 10 or 20 different models, and in which the same materials are going to be used, then it's very efficient for me to create this code once and then call this code up here, run this code, and then it will generate the materials for you in a fraction of a second. Now, for the new users, I will also say that there's another very good way to learn Python script besides the Abaqus documentation. You can also create a replay file. So every time you launch a model in Abaqus CA, a replay file is created. So whatever actions you are taking within Abaqus CA, they are written in the form of Python commands in that RPY file. So you can open up that RPY file and then see that what code it is written, and then you can kind of backtrace as to what you did. And this is a very useful way for the new users to start learning how the Python script looks like when you are working. So for example, in this creating the material, what you can do is also as well launch this Abaqus CA, create these materials manually, and then it will create a replay file in the directory, in the working directory, and then you refer back to that replay file and you can learn the commands. So you will be seeing that these commands will be generated over there. So that's a reverse way of learning it, but a very useful way for the new users. Another way is to do the Abaqus macro manager. For people who have used, some of you, who have used Microsoft Excel, you are very familiar that in Microsoft Excel we have Visual Basic, VBA, which is used to write the macros. Now for the new users, there's another very good way for doing it, and that you can record the macro and then you can perform your actions in Excel. Then you can open up that macro and see what commands were written. And in this way, you can kind of learn to do the Visual Basic macro. In a very similar way, in Abaqus, you also can do write the macro manager. You can start creating the macro manager. Then you take your actions, for example, creating the material model, then go back and step into that and then see what commands were written. So in this way, you can kind of backtrace as to what the commands will look like in Python language. Here's another very, very good small short type of kernel script for creating a viewports and post-processing. So here what I'm trying to do is I have written this very small type of script. Through this script, in the post-processing, I want to find out the equivalent plastic strain. So rather than going to the von Mises test or anything, I can get straight to the equivalent plastic strain and then create a picture snapshot of this. So this is very useful also for doing the customized post-processing. So here I will hand over to my colleague, Chris, to talk about this GUI customization, and then I will come back to present some examples.
Okay, Syed, can you see my screen? Just want to confirm.
Yes, I can see.
Okay, as Syed had talked about, I'm going to transition a little bit to GUI customization. We were just talking about kernel scripts. Now we're going to talk a little bit of what you can do with GUI customization. What we're looking at here is a slide of kind of for customization with an Abaqus CAE. We can develop a simple GUI or plugin through the really simple GUI plugin that's available within Abaqus CAE in the plugins menu. What this gives us is what we call a WYSIWYG, or what you see is what you get GUI. Basically, the inputs that are specified just get sent to the kernel.
I'm sorry, Chris, to interrupt you. We just see your folders.
Okay. How about now? Sorry.
Perfect.
Okay, let's pick back up with this. So with the really simple GUI, it's just a static GUI. You collect input from the user, and when you submit the dialog, that information gets sent directly to the kernel. It's not dynamic. You can't do anything else. A standard plugin gives you a lot more flexibility. It's called a GUI plugin. This is definitely can be dynamic, and there's a lot of different options. We'll get into that shortly in another couple of slides. You can do a custom toolbar button. These are these buttons that kind of float around in CAE. You can dock and undock. You can add your own if you want. When you press that button, it can execute a script and do something within CAE. Finally, you can move on to a custom application. Custom application is the most complicated scenario for customization within Abaqus, but it gives you the most flexibility on what you want to do. And basically, the idea with a custom application, one of the good parts to it is if you can remove certain features from CAE, maybe file menus or certain components of the file menu, certain parts of the display modules, and you can set up a workflow that for users that may be less familiar with CAE, it would be easier for them to navigate through the workflow and get to the end goal. Okay. A graph of increasing complexity versus efficiency for some of these options. So if we start down in the lower left-hand corner, we talk about manual creation. If I don't know any ways to do the customization and I just have to build the model myself, post-process the model, that's manual creation. It's obviously, I mean, there's complexity involved with CAE, but assuming obviously you know CAE, in terms of doing the creation or post-processing, it's just all manual. For creating a simple script, as you move up on this graph here, when you create the script, it doesn't involve increasing complexity, but it does increase your efficiency. And then if you move up even further, RSG, you gain a little bit, but then as you move into a standard plugin or other custom application, you really can increase your complexity of the design itself, but the efficiency gain can be dramatic. Here's a simplified schematic of how the GUI and kernel interact for a standard plugin. If we go to the plugin menu, we open our plugin. When the plugin's open, it will activate a form. Within the form, you can store these keywords and GUI commands. The form itself will actually launch the dialog box, or what we'll call a GUI window. Within the dialog box, we can collect user input. When you submit the dialog or press OK or even apply, that information is collected, sent over, populates the AFX keywords that are stored on the form. The GUI commands are issued. Some processing takes place with that particular mode, and you can perform some checks to see, for example, whether the keyword values make sense. After that, as that's going on, the final parameters are sent through a command string to the kernel for processing. And in this case, for a later example, we would be building a CAE model, and that would be the kernel method you're calling. At that point, the form is deactivated. We mentioned what a RSG plugin is, and here's an example that is available in CAE. So we have a simple dialog for creating a small plate or a plate with a stress concentration. We have 4 inputs: name, width, height, and radius. As you enter those values in and hit OK, it will go off and build the model for you. But again, what you see is what you get. There's nothing else hidden here. There's nothing that can change as you make those inputs. What we could do, though, is if we wanted to develop this into a standard type plugin, which could be dynamic, is let's say we include 2 radio buttons. Instead of just having a case for a circular hole, what if we have elliptical stress concentration? As we toggle back and forth between those 2 different radio button choices, those parameter fields could change, as well as the diagram that shows what the parameters are for the particular geometry. And finally here for standard plugins, and my colleague Syed will pick back up after this and show a number of examples. For standard plugins, you have a lot of different options. So you can create your custom dialog or multiple dialogues. You have a large variety of widgets available that are customizable. You have dialogues that can open up other dialogues. The GUI can obviously update dynamically. You can have drop-down menus that can be auto-populated. You can imagine being in CAE and you pull up your plugin, you load an ODB somehow through the plugin, and maybe there's sets that you want to look at. You can automatically figure out what sets are tied to that particular model and populate a combo box, for example, or a list. Tables can be filled with text files. Regions can be enabled or disabled. Regions obviously can be changed based on user selections, as we talked about in a previous slide. Warning and informational dialogues can be shown and posted. File menus can be displayed and added to your particular dialog, just like in CAE. Tables, as we just talked about. And finally, one of the nice things you can also do is you can interact with Abaqus CAE through a procedure of actually picking something in the viewport, and then that information get passed back to the dialog and further to your kernel script. And we'll show an example of that in one of the demos that follow. Okay, Syed?
Okay, thank you very much, Chris. And here I will just take over and present the rest of the examples here. Let me just start sharing my screen. Chris, can you please stop your share? Okay, so thanks, Chris. And now I will just go here. So this is the first standard plugin example that I'm showing you. And once again, as I told you, that there are hundreds and thousands of plugins which are available based upon the users who have developed them based on their needs. So this is one thickness mapping tool, which is once again available on 3ds.com similar learning community. It's a very useful tool for the engineers who are performing level 3 FFS, fitness for service assessment, for the structures such as such as tanks and drums and pressure vessels, and who are performing the level 3 FEA analysis. So what this tool does is this, that this plugin, that you can have any geometry like a cylindrical surface or curved surface, and if, for example, you have a case of variable corrosion, which makes the thickness different across certain patch or certain region of a pressure vessel or a drum or a tank, you can have that data in the Excel sheet and then use your plugin to call that data in and apply it to that region. So you do not have to manually define those sections and regions, and then you apply this thickness to this shell surface. And here you are seeing that by using this, you can actually succeed in defining variable thickness on this region, which can be very critical. I mean, the thickness difference, for example, between 0.355 to 0.625 inch can be fairly critical in determining whether this pressure vessel is going to be failing or not. My next slide, this is another stress strain calculator. Once again, it's a very useful tool for the level 3 FFS engineers who are performing the FEA analysis. Here on the left side, you will be seeing a very complex type of material behavior. It's which is defined by some complex equations. So what this stress strain calculator does is this, that it has all of those calculations embedded inside it. All you need to do is to specify the elastic modulus, Poisson's ratio, derating factor, yield strength, and ultimate tensile strength, and it will compute all of those parameters for you. It will do the stress strain calculation for you, and it will generate a engineering the true stress strain curve, which will then generate a material model for you. So it's very, very useful. So every time you step into Abaqus CA, you don't have to do this process manually. I mean, all you have to do, just run this plugin, and then it will perform the job for you for creating the material. Another good example where you want to define the connections between various surfaces, such as in the form of the springs or dashboard elements or MPC constraints, you can specify those surfaces, and then this standard plugin will create those dashboard or springs for the user. Another interesting example is you have created a straight face and you want to wrap it around the cylinder. Using this standard plugin, you can wrap this planar structure onto a cylindrical shape. So you don't have to create like a manually this geometry here in the CAE. A very useful application for the, so we covered the standard plugins. Now I'm showing you some examples, some very useful and important examples from the GUI plugins. So as I mentioned to you, that they look like basically a software within a software. I mean, you create this application and it's a very customized application with a very particular focus. So one of the very useful applications of Abaqus and Python and GUI is the Abaqus knee simulator, also known as AKS. So this is for simulating the implants inside a human body in place of the knee. So what you can do if using this Abaqus knee simulator is to bring in your geometry, and then what this knee simulator is going to be doing is to create a material model, assemble the components in their correct relative position, create several connectors in between them to specify the motions of femoral component, for example, with respect to the tibial insert. And using this computer modeling and the simulation, you can check it against the physical testing, and once the results are corroborated, then you can go back and perform the final fabrication. So rather than beginning from the very beginning, creating the actual product in the physical shape, and then performing the test, and when those tests fail, and then you go back over there again, that becomes a very expensive option. So here, using this approach, in this case, you can reduce the number of redesigns, you can reduce the cost and time to market, and then the patient safety increases. So this is one fairly good, useful example here for the GUI. Another example is the famous Abaqus welding interface that most of you might be familiar with it. So basically, for this application, you can create multiple welds in one model, for example, on a pipeline or on a pressure vessel. You can select the beads or chunks, and then you can simulate the welding process. How many welding paths, what is the geometry of the weld, and how the heat affected zone stresses are looking like. So this is what this Abaqus welding interface does for you. So this another fairly good example of the GUI plugin. One more example, another example for the GUI plugin is to model a fracture. create the fracture geometry for the FEA-based fracture assessment in a pipe model and applying the loads and boundary conditions to it to help you assess whether the crack will develop under the given loading, and then doing the post-processing of it. Another GUI example is the bound composite model for Abaqus, for example, for the pressure vessels that have composite materials, and you can specify them layer by layer. So that GUI tool also helps you in developing that type of application. For the engineers who are working in the subsea industry, oil and gas industry, they are familiar with what the jumper is. So a jumper is basically an inverted M shape or some other U shape type of design that is used for connecting from the wellhead, the hot oil, the hot product from the wellhead to the nearby plate, or from different plates or plants to each other. So using this plugin for the jumper, you can actually input your coordinates, create a model of a jumper, and then basically you can see different tabs here. Using these tabs, you can specify the material properties of the jumper, the water and the density of the product, etc. And then you can simulate it. You can find out what the strength of the jumper is and perform the strength analysis on it. In the last example that I'm going to be showing you, this example is related to not the automation, but it's a customization. So different from the other ones in which I was showing you the standard plugins, or we were talking about those kernel scripts. It's a user subroutine. So as I mentioned to you at the beginning of the webinar, that the user subroutines are something that you use when you have very complex loading condition or the boundary condition or very complex material model. So this example that I'm showing you here is the CREEP, is to develop the CREEP material model based upon American Petroleum Institute standard 579. So that model is not available by default in Abaqus CAE. That is why a user needs to define a user subroutine that can be referenced by the input file, and that can simulate the model of this CREEP behavior. So with this, I will hand it over to my colleague Chris Hagoda for showing the last part, which is the demo of this presentation. So Chris, you can take over, please.
Okay, Zaid, I just want to confirm you can see the demo that showed?
Yeah, sure, Chris, I can see the demo.
Okay, we just finished talking about customization of Abaqus, a customization within Abaqus CAE, and now we're going to get into two different demos. For these two different demos, we're going to look at a kernel script demo and then also a GUI demo for an Abaqus CAE plugin. For both demos, the Python API application programming interface for Abaqus is used to interface with CAE. For the kernel demo, the Abaqus scripting interface, or ASI, is used to help create the Python script that will be used to build the entire finite element model. In this case, it's a simple pressure vessel, but the entire geometry, loading, and mesh will be created. Two additional automation options will be included in the script, and for these cases, it will be a job submittal locally, and then also a simple post-processing option for the contour plot. So we have different options to run the script. We can either do it right when we open it up, we can do it from the file menu, or from the kernel command line interface. If we have Abaqus just open, we'll hit run script in that dialog, and here's the actual scripts. The 1_ script is the script we're going to run. The other two are modules that will be imported so that we can access functions within them. We hit OK, and we can see the actual model is running and completed now. In the message window, we see print statements that have been issued to help the user identify what's been going on in the processing of the kernel script. Here we can see the model. It's just a simple pressure vessel with two flat end plates. It has external and internal pressure applied. We have double bias seating along the length. We have edge seating specified by size along the edges at the top and bottom. And then we have our boundary conditions, the displacement boundary conditions fixed on both ends. Okay, if we look at the model tree specifically for this particular model, the PV model as shown here, we can look at the part itself that's been created. We can look at the datum planes, different cells that have been partitioned. We have sets that automatically been created, surfaces, a section assignment, and finally loads and boundary conditions with internal and external pressure that have been created, as well as the bottom and top plate ends that have been fixed. Okay, let's inspect the script a little bit. So here's the Python script that was used to build this. At the top of the script, we have some import statements. We have parameters that are used here they're specified by the user, and they're here to help build the part. They're the main parameters assessing part creation and mesh seating. We have additional parameters defining the pressure values, as well as these flags for job submittal and post-processing. Down below, we have the main coordinates for the exterior of the part. Then we move into part creation. We call a function in one of the modules for part creation. We create our surfaces, our sets, our materials and sections. Finally, we get into creating partitions and mesh seating. We have double bias seating, as we talked about, along the height of the cylinder, and fixed edge seating here. We specify element type. We mesh the entire part. We create an assembly. We create our step, apply the loading, and finally apply our boundary conditions. As I mentioned, we could have two additional options if those flags were set to true. We could submit the job locally, wait for completion. Once it's done, it would process the next part of the script. In this case, it would do a simple post-processing for a contour plot for the S33 stress component. If we move back up through the script here, one of the things I want to point out is this findApp method. It's part of Abaqus Python, or Abaqus Python. And this method in particular is used to help identify, through coordinates, identify the geometric entity that you're looking for. And obviously, it's very important for these geometry creation scripts. Okay, so here's our current model again. We come back to the script. We can go back to the parameters, and we can comment out run 2. And now we'll run one again. And if we run this, we had some different parameters, so we should expect to see something different. So here we see our height of the cylinder has changed. If we go back and turn on the mesh has changed as well. And we can also verify that the loading is still the same because we didn't do anything with that. We still have our fixed end boundary conditions, and we have our internal and external pressure applied. So with this example, we're able to go through a kernel script demo. We're able to modify this kernel script parameter contents and show how we can quickly build a model. Now we're going to go into a GUI demo, an Abaqus CA plugin demo, where instead of having to manually manipulate the kernel script, we're going to use the inputs collected by the GUI to change the model. With that, we'll proceed to the next demo. Okay, for this second demo, as I said, it's going to be an Abaqus CA plugin demo. The Abaqus GUI Toolkit, which is an extension of the Fox GUI Toolkit, is used to create the Abaqus CA plugin. This plugin is a GUI that wraps around the kernel script that we just discussed. And instead of having those parameters hard-coded into the script, we're going to collect the input from the user in the GUI. And this can be done in various ways that we talked about a little bit before. You can have text fields, radio buttons, you can have lists, you can have tables. There's a variety of different options. Alternatively, you can have the user interact with Abaqus CAE and select something, and then that information can be sent to the kernel script. Okay, so for this particular example, We have Abaqus CAE already up just like before. We'll close the dialog that starts off Abaqus CAE, and then we'll look at actually loading the plugin. We go up to the plugins menu. We select the plugin of choice. Here it's called PV Builder. It launches our dialog. It's just a single dialog for this particular example. It has some buttons at the top. There's some buttons down below. It's 2 tabs. The buttons at the top, for instance, could open a file, save a file, open a user manual. You could also put file menus up above them if you wanted to, just like the structure you see in Abaqus CAE. Down below, we have our custom buttons, and you could put custom icons on them. One here will be used to create the model and submit everything. The other one can cancel out, just like above on the right-hand corner. For this particular tab, we're going to collect input from the user that we can be sent over to possibly a text file, for example, to be stored later so that we can keep track of what analysis was run. We can move into the next tab. It's called Model Input. This is our main tab for this GUI. This is where we're going to collect all the data for processing our model. The geometry input portion has the inner radius, wall thickness, and height specified with 3 text fields. We can specify the boundary conditions, the mesh controls through 3 radio buttons, the job controls. For job controls, we have checkboxes, and if we submit a job, we have the option to display results. If you don't submit a job, then you can't display anything, so the checkbox is grayed out or disabled. So that's kind of the dynamic portion for that particular area. We have displacement boundary conditions. We're going to start with a fixed ends, just like we did with the kernel script. Here we're pointing to a informational button. Just like you see in CAE, you can put these all through your GUI as needed. And if you click on this button, it's going to pull up a separate dialog. And this informational dialog will help give the user information needed to enter anything they want to in the GUI for that particular region. For this region, we're talking about the geometry specification. So we see the cross section of our part, the thickness, the height, and the radius of our vessel are shown here. In addition, you can specify notes to help guide the user for a more complicated setup. And then you can dismiss the dialog when you're done using it. If you want to pull it back up, you can move it around. You can keep it up as you need to, but we're going to dismiss it for this particular example. For the traction or pressure boundary condition, we're going to change the external pressure. We're going to set it to near 0 at 1, and we're going to keep the internal pressure where it is. Now, one thing we could do to make changes to this particular region is, let's say you don't want to always specify internal and external pressure, and you don't want to go back and modify your kernel script. What we could do then is we could put radio buttons up above. We could specify internal and external pressure in a both scenario. If you specify one, just the internal, you would just see the single text field. If you specify both, you'd see both. We're going to keep the coarse mesh alone, and we're going to submit the job here. So here's our model. Well, all we did is we press a button, collected an input, and it submits it to the kernel, and we build our model. If we change it to fine mesh, we can get a slightly different geometry with a finer mesh. Well, we get the same geometry just with a finer mesh. We can go in and check the loading conditions again. The pressure still applied the same, and our end displacement restraints are still there. Okay, so let's go into our next radio button for the mesh controls. We looked at coarse and fine. We also have custom. What does custom do? Well, custom automatically resizes your dialog. It puts additional text fields that are available to the user to allow them to specify their own custom seating that they want along those certain edges that are defined by the kernel script. Here we can specify, we're going to specify actually larger values so that we can actually submit the job and take look at the job control portion of the script or of the GUI. So we're going to just specify larger values for some of the seating. And then the growth factor we're going to make pretty long or pretty large along the length of the height of the cylinder. And you notice that with the custom mesh, as you press that radio button and you move away to the coarse, it will actually resize and remove those extra text fields. So we can see it as a very coarse mesh, something you obviously aren't going to use in an analysis per se, but for this demo, it's very practical because it will run quickly and allow us to show the other parts of the GUI here. So we submit our job. If we look down below in the message area, it's gone through the processing. It's now creating and submitting the job locally. And now it's in that wait for completion area of the kernel script. So after it goes through the typical Abaqus CAE pre-processing and submits the job, once we finish that, we can get into the second part of the script where it would actually post-process the results. So within a second here, it should complete. Analysis is completed. And now it does the simple post-processing. We go back into visualization, and we can see we have S33 displayed, just like our kernel script expected. It pulled up the ODB for us, and we have a simple display. This is a very simple case. You can obviously go on to as much as you want in terms of complexity, but for this demo, this gives you an idea of just how you can put everything together. So there's one additional component to this that we haven't talked about yet. And what this will be is related to the displacement boundary condition. We alluded to the point earlier where you could interact with CAE. So I've created a pick button here. If you select custom boundary condition, we can actually select the area we want to apply the boundary condition instead of using the fixed regions or the fixed vertices. So in this case, we actually pick the pick button. It goes through, submits the job in terms of creating the model, and then gives us the option, as you can see down below in the middle part of the screen, select vertices for your fixed boundary condition. So I'm going to select a couple vertices on the top edge of the cylinder. I hit done, and everything gets submitted for me. If I go back and check the loading, we can see that those fixed restraints on the top and bottom edges are no longer there. They've been replaced by these couple vertices. If we aren't happy with that, we can obviously go and change that again. We select our pick button, it processes, creates the model. We go through and select some additional edges. Let's say it's on the side and welded to something. And again, once we hit done, everything gets sent to the kernel and it creates those boundary conditions for us. And sure enough, those vertices have been replaced with ones on the side edge. So there's a lot of different things you can do with the allowing for someone to actually interact with CAE by introducing an AFX procedure with a pick step. So this gives a lot of additional flexibility. This GUI, I mean, you can obviously make it as complex as you want. There's a lot of different options available. The idea of wrapping a GUI around a kernel script provides the extra control of your code, and it's very portable, whether to Windows or Linux, or installing in your Abaqus plugins directory so that anyone can easily use it and not have to manually make changes to your kernel script. And obviously it gives you more flexibility in terms of additional things you can do and provide access to the user. With that, That's the completion of both of the demos.
I do have a question on the demo. Is this okay time for you, Chris?
Yes.
One user asked, do you have a macro for automatic contact detection and contact definition?
No, I do not. I do not have that. I mean, it could obviously be created, but I do not have that.
And also, hi, this is Arindam here to add on to the response. I mean, if you're using Abaqus, it does have a general contact definition that have an algorithm, a very robust algorithm, and it has been improved quite a bit over the years. So if you have any specific question, we can look into your problem and see. In terms of a particular kind of problem, if you need something very customized, yes, we can develop one, but Abaqus already has a general contact definition. Yeah.
Do we have time for a couple more questions?
Sure.
Right.
Yes.
Do you help with developing methodology and workflow that can then be automated?
Yeah, I can take that question. So yes, we do. I mean, we work in two modes, I would say, for customization and automation. One is where you already have a workflow or methodology, and we will implement on the automation side with scripting and all. Another is we can also work in a consultative way to develop the methodology and the workflow and then implement it. So depends on what your needs are.
Okay, thank you.
Yeah.
How do you create a GUI plugin from script?
Chris, you want to take that? I think it's more a detailed thing. So.
Okay, how do you create a GUI program from script?
Yes.
Let me see if I can just talk a little bit about the difference between kernel and GUI script creation. So I'm not sure if I'll totally answer your question, but I'll try here. So the kernel script, we actually looked a little bit at the details. We saw what's in there. When you get into a GUI plugin, an actual standard plugin or a GUI, now you have your kernel script, but then you also have to understand the interface with the Abaqus Fox or the Abaqus GUI toolkit. So you would actually be creating separate GUI code in addition to your kernel code, and then those tie in together. The nice part with the kernel code is you do have your replay file to kind of give you a start if you're new to it. With the GUI code, it's not that easy. The complexity going from kernel to GUI development is quite significant. And especially I think with the Fox toolkit with Abaqus CAE, there's definitely less examples of it out there. Hopefully that gives you some insight.
Yeah, I also want to add one thing to what Chris said. So my personal experience of learning GUI, you can start with the RSGUI. I'm talking again about Abaqus centric. So that will give you a very good idea about how the information is flowing. So eventually you want to read the data from an input and then pass on to the parameters that works with Abaqus internally. That can be a good start. So you look at it, how the structure is and all, start with a small problem and then create complexity in it. Also in Python scripting itself, there is a get input kind of functionality available, which creates a very simplified GUI. I think we had one slide kind of said that. So those very simple ones you can there are ready piece of code available, so you can just call in the function and it will create. But yes, to add to that, so GUI scripting can be very involved as a process, and but it's also at the same time extremely powerful. So you might want to balance depending on your needs and your expertise, and we can always help you with your needs as well. Thank you.
Thank you. Another question is, can you run the same models with change in boundary conditions other than using batch file? Who wants to handle that question?
Arinda, do you understand? I'm not sure I quite understand the question by batch.
I think I'm kind of understanding it. I mean, other than using a batch file, what I can say is that in the script, you can kind of mention that run the one job after the other. So yeah, I think that it is possible. And also you can perhaps, as I had discussed also in the eyesight, when I was showing the eyesight, that you can embed this type of system within eyesight, and then it can automate the job submission for you by doing the changes in the boundary conditions. So you do not necessarily have to run a batch file. You can automate this process within eyesight.
Great, thank you. Another question is it possible that the Python modules installed in the base environment can be executable by Abaqus environment?
Chris, do you want to answer this question?
Yes, could you repeat the question one more time?
Sure. Is it possible that the Python modules installed in the base environment can be executable by Abaqus environment?
So if I'm understanding the question correctly, Abaqus has its own Python installation. And then if you install, say, a prepackaged Python installation like Anaconda or something like that, or even just a base Python installation, no, that's very difficult. I've tried doing that myself. Basically, unfortunately, it seems like you're limited to accessing the Python installation tied to Abaqus itself. And there's a lot of, I think, I don't know all the ins and outs, but there's a lot of dependencies between the Python packages. And when you start trying to mix and match installations, you're going to run into problems. The good part about Abaqus Python, or the Python installation within Abaqus, is with the newer versions of Abaqus, whether it's 2020 and or later, they're going to start introducing additional modules such as matplotlib and others, so that the amount of modules available to you that are more similar to maybe a standard Python or expanded Python installation will be greater.
Thanks. Another question. We do not have eyesight, but still want a DOE workflow. Can I create the same using Python scripts?
Yeah, I'll start answering that, I guess. My experience with, I have not used eyesight as much. My experience with scripting, though, and GUIs, with scripting, you can pretty much do what you need to do through multiple scripts. Scripts can call other scripts. So obviously, depending on the complexity of your design of experiments, the power of eyesight, and being able to combine multiple tools gives you more flexibility. But if you're just working directly within Python and Abaqus, then I can't see why you wouldn't be able to create the whole workflow with Python.
So yeah, so Chris, to add on to that, so I have used eyesight extensively with also my background in reliability and DOE and all optimization. So I'm a big kind of fan of using the tool for their intended purpose. So if you look at what eyesight does, it's already a very easy way to automate your workflow. But to automate your modeling and simulation, you want to go into Python scripting, which is talking with Abaqus kernel and also some of the GUI aspects and all. So I would probably choose certain things in eyesight because it is a very robust software. It has all the different formulations already involved in it, and it might not be worth spending the time and do 30% of what eyesight can do. I would probably focus for eyesight strength, and anything to automate on your modeling side of things, I'll probably focus on the scripting. And also just want to add to the previous question about Python separate installation. So there is also a version difference between the latest version that is supported by python.org and what is the Abaqus. And we recently had some experience using Anaconda. So we did the post-processing. So we took all the output from Abaqus. Once you get the output, it's just numbers and text and all. that you can use with any functionality of a standard standalone Python installation. So you cannot get in the environment. I think there will be a lot of interdependency and all that will not work. But you can always extract some data out of Abaqus and use the full extent of Python capability. So that may be one way to solve for it. And we have some examples and all. If you are interested, we can show you how we are doing things in a more complex way, I guess. Thank you.
Thank you. We have several suggestions for more in-depth webinars, so thank you for those, and we will look at them and try to get them scheduled in the future. We have a question here. Is it possible to automate geotechnical foundation problems where we will have to cut the soil mesh and assemble the foundation mesh into it?
Yeah, we can do that.
Okay. Yeah. Also, are there effective residual stresses in the initial soil conditions?
We can bring in an analysis aspect of it. Yeah, okay. We can map.
Is it possible to automate models with nonlinear compression only springs and the like?
You can. Some of the functionalities, I think I've done one similar example before. Some of the Abaqus functionalities are not available through GUI. If you get into those, the way we have modeled it before is also to modify like a text file. So you get the input file, you create a base input file, and then go in there in the base input file, and then have a Python script that basically, based on your data, it modifies the text file, and then you submit it for analysis. So there are many different ways to tackle it, and we have done something similar, so we can discuss if you have a specific case in mind.
Thank you. Is there any way to generate SFD and VMD of a structure in Abaqus?
Shearful diagram, yeah. I mean, generally, there are the output variables which allow you to develop the shear force and bending moment diagrams,
yeah,
such as and force.
So one thing I want to emphasize. So what we are trying to mention here, pretty much anything. I don't want to say 100%, maybe very close to 100%. Anything that you can do using Abaqus, either through input file or clicking anywhere in your screen, can be done through scripting. And if you have scripting, then it requires just some input, and you can ask those input through a GUI interface. So to answer the question, anything that can be done pretty much in Abaqus, and these are good examples that Abaqus already stand. I mean, you can just go on the output file and you can look at all this, or you can extract the data. So plot, you can then automate the plotting process. So pretty much all this thing can be done using scripting. It's extremely powerful. I myself has used ANSYS APDL and all. I mean, of course, there can be differences in opinion, but my experience was this scripting in Abaqus is very, very powerful on what you possibly can do. And I would strongly suggest, if you are developing a workflow or even like a team and you want to do a lot of kind of repeat analysis, always look from scripting point of view. How can I, from the very first day, automate some of the aspects? You don't have to automate the 100% workflow. You can start with 20% and gradually build up on that. Thank you.
Thank you. Last question. Could you share references or knowledge sharing databases for the geotechnical and compression only nonlinear spring automation, as there's very little data available on the internet?
Yeah, I will suggest maybe you can drop us an email. So we will share the contact information. So we can get back to you and see what exactly you are looking for, and we will be more than happy to share what we know. Thank you.
Perfect. With that wraps up our webinar. I'd like to thank everybody for coming today, and please be on the lookout for our next announcement of our next webinar. Thank you very much, gentlemen.
Thank you.
Thank you.
Thank you.